Okay, so this is the key. But if I enter this into my calculator, and maybe some of you, oops, zoom 6, you didn't see anything at first. Okay, but we know that the vertex is 1520. We read it off of the equation. So 15 is here, and then 20 is up here. So I need to make some changes to my window. I'm going to go X max. I'm going to change that to 30, let's say. Hit graph. Okay, now I see both legs. That's good. I still want to see the top, right? I know that the vertex is up here. I'm going to go window, Y max. I'm going to change that to 20 is probably not a good idea. I go a little bit higher than 20. Okay, then you hit graph. Okay, now you see basically the main shape, the parabola. You see that. But we still want to see the y-intercept. So here's some of you, I like, for example, over here, you can probably not see it, but they try to solve it algebraically, right? They let y equal to 0, right? And then they figured it out this way, which is actually a good strategy if you're stuck. Okay, we know that our y-intercept is negative 4,000. But sometimes, I would say actually this one can be done most of the time. This works. Let me just make this a little darker here. There. If you go second trace value and you let x equal to 0, this is the one thing the calculator can find without seeing it. I will not say always, but most of the time. So you know your y-intercept is negative 4,000. So you need to decrease your y-min significantly. So you go to the window, and y-min, I'm going to go negative 4,100. Right? Now you see the y-intercept there, and the vertex looks like it's on the x-axis, but it just looks like it. It's not, right? We know it's above it. So, but now you see the whole thing, all intercepts, everything is there. Okay? This is what I would expect you to do here in this particular case. Another thing is zooming in is also a good option. Like if you want to zoom into the parts up here, you can just go travel to it and then hit enter. And then if you want to zoom in even more, right, you want to zoom into this area, zoom in again, and there you can actually see that it's crossing it twice and the vertex is right there. You already know what the vertex is, so you technically don't need to find it. You just need to get these ones. And then if you want to zoom back out, you just select zoom out and then you just hit enter. Oh, this is going to backfire. I'm going to have to go to here and zoom out. Okay, so now it looks different than what we had earlier, but it still works. So finding the x-intercepts here, okay, you got to pay attention to this. It can be done, second trace 5. Just make sure I'm going to travel this way. So now it's going to find me that first one. Okay, so enter, 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 and it's negative 13.94. Okay, that is this one right here. The second one, if you want to find it and it's so cluttered there, you just got to make sure you do this again and then travel a little bit over to this side. Because it's always going to find the one that's closest to it. Okay, that's what it's going to do. So if you're on this side, it's going to find the first one it hits coming from this side. So enter, enter, enter. That's where you get the other one, 1605. So that's the sure way of doing this and getting that right if you don't want to zoom in. Okay. If you do this from both sides and you get the same answer, it means that there's only one x-intercept. Okay, that's what it means. Like if you're coming from this leg or that leg, it's going to just find the one. Okay. Don't forget that if you want to find the x-intercept, y2 has to equal to 0. Okay. Now, for graphing, when it comes to graphing here, I want all intercepts there. So for my y-axis, yeah, you needed to use 500 or 1,000, right? And label a little bit on each side of the axis. And then here I went up by 5s, right? And so here's the vertex and the two x-intercepts are very close together. There's my y-intercept, and then so you go from here to there and then try to make it symmetric going this other way. Include your equation and you're good to go. Okay, so I scanned this already. I have it ready to be posted. I will post it for you, and I would say try it. And try this on your own. It's very good practice for you to do so, okay? All right. Grab your booklets.